Okay, so today we're diving into AI,
Okay.
but not the usual like algorithms and code stuff. We're going deeper,
Mm.
like way down to the
Yeah.
semiconductor industry,
Right.
because that's where it gets real, the future of AI. But
Abs-
it's not just code, it's chips.
Yeah.
It's like physical,
It's the metal.
Yeah, exactly. And to help us unpack all of this, we've got two amazing guests. Dylan Patel from Semi-Analysis.
Well, yeah.
He's the AI hardware guru.
Really?
And John Y. from Asianometry.
Love that chance.
I know, right? He can connect anything to semiconductors, like anything.
This is the best.
So first up, let's set the stage. Imagine Xi Jinping going all in on AI.
Okay, I'm intrigued.
We're talking full-on scaling mindset.
Scaling. So that's where you're aiming for these huge AI models. Bigger, more powerful.
Think trillions of connections, like the mother of all brains.
Right, but those brains need power. And I mean a lot of power.
Data centers the size of cities.
Exactly. It's insane how much energy these things need.
It's mind-boggling, and that's where John Y. he drops this crazy comparison, Yugoslavia's nuclear program.
Hold on, what?
I know, right? It sounds random, but it's brilliant. See, Yugoslavia, they didn't have the resources to build a nuke from scratch, so they got creative.
Okay.
They found people who knew how, smuggled parts, basically bootstrapped the whole thing.
Wow.
John's point is, China could do the same with AI. Poach top talent, leverage their knowledge, centralize resources, boom, instant AI superpower.
Like Crash Course, but for AI domination.
Exactly, and it all comes down to semiconductors.
Which brings us to
Oh yeah, this is a good one.
by Eng Mong Song,
The name might not ring a bell.
but he's kind of a legend.
Oh yeah. We're talking chip-making rockstar.
Worked at TSMC, then Samsung, now SMIC in China.
And everywhere he goes, chip development explodes.
He's that good.
It's kind of scary how much power one person can have, right? But it gets me thinking, what if you could pool a whole nation's resources into AI?
Oh, interesting.
Could China, with their more centralized system, pull ahead?
It's a fascinating question. On one hand, centralization means focus.
Right?
Like they could build a massive data center in a heartbeat if they wanted to.
I mean, John talked about converting an entire aluminum plant overnight.
Exactly. But then there's decentralization.
Which is more the U.S. approach, right?
Right. Lots of different players, different approaches. It's messy, but it breeds innovation.
Like 1,000 flowers blooming.
Exactly. You never know where the next breakthrough will come from.
It's like a trade-off, right? Centralized power versus this free-for-all of ideas.
And speaking of trade-offs, the U.S. export controls on chips. That's a big one.
Yeah, trying to slow China down by cutting off the tech.
But Dylan brings up an interesting point. It's like that Yugoslavia thing again.
Restricting access can backfire.
Exactly. Makes them even more determined to figure it out themselves.
Like trying to hold back a flood.
Exactly. They'll just find another way around.
So maybe not the best strategy long-term.
Well, it's complicated. It might slow them down in the short term.
But in the long run, they might just come back stronger.
It's a risk, for sure. But then there's the whole complexity of chip making itself.
Oh yeah, I was blown away by that. Like 2-nanometer chip making, it's insane.
Dylan described it as like meat slurry.
I know, right? Like what does that even mean?
It's just mind-bogglingly complex.
Billions of transistors, smaller than a fingernail. It's like
building a watch, but inside of a grain of sand.
and each part has to be perfect.
Oh, yeah. Even the tiniest flaw can ruin the whole thing.
Makes you wonder, why not just get AI to do it?
If only it were that simple.
I mean, we've got AI writing poetry, composing music.
But chip design, it's a whole different ballgame.
More complicated than Shakespeare.
In a way, yes. It's about understanding physics, electrons, the flow of energy.
So our current tools aren't up to snuff.
They're good, but they're still based on, like, classical approaches.
Not the AI magic we hear so much about.
Not yet, at least. And there's another problem. We need more chip designers.
We don't have enough people who can even try to design for AI.
It's a very specialized field.
So we're stuck.
For now, maybe?
Hmm.
But Dylan argues CEOs are betting big on AI anyway.
It's like that all your eggs in one basket kind of thing.
He calls it a Pascalian wager. Like, the potential payoff of AI is so huge.
That it's worth the risk, even if it's not guaranteed.
Exactly. They can't afford to be left behind.
High stakes, for sure. But it makes me think, both Dylan and John, they've spent years in this world. What advice would they give to someone just starting out?
John's a big believer in finding your niche.
Don't try to be a jack of all trades.
Exactly. Find that one thing you're passionate about and become the expert.
Like the memory guru.
or the chip design ninja, whatever gets you excited.
But how do you even know where to begin? There's so much out there.
Yeah, it can be overwhelming.
So Dylan says, be a sponge.
Soak it all up.
Go to conferences, read everything, talk to people.
Yeah, find mentors.
Ask dumb questions. Everyone starts somewhere, right?
Exactly. Nobody's born knowing this stuff.
It's inspiring, actually. Like, the future of AI
It's world-changing technology.
could come down to some kid tinkering in their garage.
Absolutely. Just driven by curiosity.
It's a reminder that anyone can make a difference.
You just need passion and dedication.
And a love for meat slurry.
We'll meet me up that.
Had to get that in there one more time.
Fair enough.
But seriously, folks, this whole deep dive has been about opening your eyes.
To this hidden world.
That's shaping our future.
The future of AI, it's not just about the algorithms.
It's about the hardware, the chips, the people who make it all happen.
And it's a future full of possibility.
So if you're feeling inspired, go out there and learn.
Explore, experiment.
Who knows? Maybe you'll be the one to make the next big breakthrough.
That's the beauty of it. Anyone can join the party.
Exactly. So that's it for today's deep dive. Thanks for exploring the world of semiconductors with us.
It's been a blast.
And until next time, keep those chips running.